Okay, for number 5 from the practice paper A, International A-Level P1 paper, we're given two equations. One of them is a linear, one of them is a quadratic. Part A is asking us to solve the quadratic equation, which is x squared minus 10x minus 20 equals 0. Okay, q of x equals 0. Alright, to solve this equation, we know that in the form of the answer that we've been asked to give it in tells us that can't be factorized, so we don't have to even bother trying. And we have a choice. Either we can use completing the square, or we could use the quadratic formula. This looks quite easy to do with completing the square, so that's what I'm going to do. X squared minus 10x equals 20. Then I'm going to complete the square, so this is going to be a square bracket. I'm going to write my x, I'm going to write minus, I'm going to write a half of this coefficient, and then I'm going to take away the square of this number here. And so we get x minus 5 squared minus 25 equals 20. Now, just to explain this a little bit, now x squared minus 10x, okay, to complete the square for that, you write your square bracket and you write half of this coefficient with a minus if there's a minus there. Now, if I left it at that, that will be x squared minus 10x plus 25. We don't want that plus 25, you can see, it's just x squared minus 10x. That's why we always take away the square of the number in here. Okay, that's why we have to take away this 25. And then that's equal to 20. So in the first step, what I did is I isolated the x squared and x terms. Second term, I've completed the square. Now I have to add 25 to both sides. So I have x minus 5 squared is equal to 45. So now I'm ready to start solving this. So I can now take the square root of both sides. So I have x minus 5 is equal to plus or minus the square root of 9 times 5. Okay, so I have x is going to equal 5 plus or minus, now the square root of 9 is 3 times root 5. Okay, so I basically well, let me just I skipped a step here, so some of you will be fine, or some of you might want me to not skip the step. So what I've done is I've taken the square root of both sides. So x minus 5 equals plus or minus the square root of 45. Don't forget the fact that when you take the square root of both sides, when you take the square root of something, you can either have a positive or negative value. So x minus 5 could either be positive root 45, or x minus 5 could be negative root 45. That means x is equal to 5 plus or minus the square root of 45. Now this is not the answer that's required, okay, because we have to have plus or minus 3 times root something. So obviously this third can be simplified. Now it's a really important, okay, many students will lose marks, and I got a comment on one of the videos that, oh, you know, it seems like the videos for the January paper says it seems like that I did quite well from the answers that I can see, but you know, I got a D. Now I saw some of my students' scripts who took the exam in January, and one particular student, he actually did really well. He got 71 out of 75, and which was a UMS of 100%. But anyway, he basically lost a few marks for just something like this, exactly like this. So he goes and he writes down the answer as, okay, that's 3 root 5, because you know here this will become 3 root 5. Now if I put root 45 into my calculator, okay, if I put 5 plus root 45 into my calculator, you'll see what comes out. And this is the reason why he lost marks, because they want you to show steps. So 5 plus root 45, the answer will give me it will give us 5 plus 3 root 5. So you can just write that just by typing in a calculator. So that's what they are aware of, and that's why you have to show your steps clearly. Okay, so what you have to do in this type of situation is you have to say, okay, this is the same as root 9 times root 5. 9 5s are 45. So you split it up into the square and non-square part, and then you say x is equal to 5 plus or minus 3 root 5. So losing marks like this, a few in one question, one in another question, they eventually add up. Even if you know what you're doing in general, sometimes you can lose a lot of marks from you know, making mistakes like that. Not mistakes, just skipping steps. Okay, so this is important for you to realize. Okay, so here we've answered x equals 5 plus or minus 3 root 5, where a and b are integers to be found. So it's better for you to say a equals 5 and b equals 5. They're both equal to 5. 5 plus or minus 3 root 5. Okay, so it's better for you to do that when it says where integers to be found. Sometimes it says in the form and that's it, without integers to be found, then you can leave your answer like this. If it says where they're to be found, it's best for you to continue to say what a and b are according to the way it's written there. Okay, so that's part A, solving a quadratic equation by completing the square. Part B says sketch the graphs of y equals px and qx on the same set of axes. Label all points where the curves intersect the coordinate axes. So we got y equals px, so px equals 3 minus a half x. You have px is equal to 3 minus a half x. And you have qx is equal to, you've got x squared minus 10x minus 20. X squared minus 10x minus 20. Okay, we already solved that equation over there. Anyway, okay, so now for p of x, I want to sketch this. This is a straight line. A straight line, you only need 2 points to be able to sketch it, to draw it. You have to know what points it passes through. So this would pass, if you put x equals 0, you can say y is going to be 3. So we know this passes through the point 0, 3. Okay, and for example, if you put y equals 0, if I put y equals 0, I'll have 0 equals 3 minus a half x. So I can say that a half x, if I multiply by 2, I'll have 0 equals 6 minus x, so x equals 6. Okay, so that's the point 6, 0. So I know it passes through these 2 points. Okay, so I can draw the line. Very simple. So let's make a little pair of axes. Let me do it with an arrow so I can show the x and y axis. Okay, so it's going to go through 0, 3 and 6, 0. That will be a straight line. As you can see, it has a gradient of a half, negative a half. So that's y equals. And now we have to draw the graph of q of x, which is y equals x squared minus 10x minus 20 on the same pair of axes. So I need to find where this is going to cross the 2 pairs of axes, the y-axis and the x-axis. Okay, so let's see. Well, we know where it crosses the x-axis already from these answers, 5 plus 3 root 5 and 5 minus 3 root 5. Now what I'm going to do is just to make sure what the values of those are, so I know which side of the y-axis to put them on. Okay, so you got 5 plus 3 root 5. Now that gives you 11. So one of them is over here, 11 point something. Okay, it's 5 plus 3 root 5. I should write it in the form that is given, the exact form. 5 plus 3 root 5. Let me write that here. 5 plus 3 root 5. Pen is lagging. Root 5, and we've got 5 minus root 5. Okay, so let's go back and put the minus there, and that gives us negative 1.7. So it's somewhere over here, minus, this is 5 minus 3 root 5. Okay, that's that value there. Okay, so now we know that this graph passes through these 2 points because that's when y equals 0, it crosses the x-axis, and we know that it crosses the y-axis when when y is minus 20. When x is 0, when x equals 0, it crosses the y-axis. That's when y is minus 20. You can see that from the equation of the graph, the original equation here. The y-intercept is minus 20, so it's going to go down through minus 20. Let me just make that a bit longer. So it's a quadratic. It's going to come down through here, minus 20 somewhere down here, and then it's going to turn. That's minus 20. Make it clear that's a minus so that we don't lose any marks. So that point here is minus 20. Okay, so it's going to come down, then it's going to go back up to here. So it will have this type of shape. Come down. Try and make that a bit straighter. It's a bit difficult with this pen, as I said before. Just come down. I'll have to modify it a bit. It's going to come up and go like that. Okay, what I'm going to do is I'm going to just move these things a bit to make it fit. Okay, it's just a sketch, so you don't have to be too accurate. Whoops, I'll just do that one again. 5 plus 3 root 5. Okay, so I'm just trying to fiddle it a bit. 5 plus 3 root 5. Okay, so as long as you have, it's a sketch, as long as you have the places marked where it crosses the axes. Okay, and for both of them, so this is y equals, this is y equals q of x, and the other one is y equals p of x. This is y equals p of x, 3 minus half x. Okay, that's fine. So we have drawn the graphs, and now we have to go on to part C. Now for part C, we have to find or use an algebraic method to find the coordinates of the points of intersection of the graphs y equals p of x and y equals q of x, which we just sketched in part B. So we want to find when these two graphs intersect. They intersect at these 2 points. Okay, so what do we know about these 2 points? Well, at these 2 points, the two graphs are equal to each other. Okay, they share the same x and y values. Okay, so so basically they intersect when p of x is equal to q of x. That's where they'll intersect. So that's what we need to do. We need to find when p of x is equal to q of x. Okay, so let's just do that. So we can say x squared minus 10x minus 20 is equal to 3 minus a half x. I'm going to multiply both sides by 2 to get rid of the fraction here, just to make it more simpler. 2x squared minus 20x minus 40 equals 6 minus x. We want to solve this as a quadratic equation, make everything on one side so it says equals 0, so we can then use a zero product property to solve it. The only x squared term is the 2x squared. You got minus 20x plus x, which is minus 19x, minus 40 minus 6, which is minus 46, and that's equal to 0. So I need to solve this quadratic equation. The way that it mentions us to give the answer here, doesn't seem to be any third type of form mentioned, so I guess we can factorize. So let's go to factorizing, so we can make our little window for splitting the term. So we've got 2x squared and minus 46, and in these two places I know these two numbers multiply to give me negative 46 times 2, which is 92, negative 92. So I'm looking for a product of negative 92x squared, and I'm looking for a sum of minus 19x. Let's just say 92 here. What happened there? So the product is minus 92x squared. Okay, so the product is negative 92x squared. Okay, so two numbers multiplied to give me 92 and add to give me minus 19. Well, they're both opposite signs because it's a negative product. Okay, so let's think of all the ways of getting 92. We got 92 divided by 2. That won't give us a difference of 19. No, 92 divided by 3. Does 3 go into 90? 92, 3 into 9. No. 4. 92 divided by 4. 4 goes into 9 2 times. Remainder 1. Remainder 1. So that's 23. 23 and 4. Difference is 19. Yes. So it's minus 23x and plus 4x. Okay, so those are the the numbers I need. Let me get rid of this now because I have to use it, space, for factorizing. So now I can factorize. I found the two numbers that I'm looking for. So now I can see from these two terms the common factor is just x. I'll write x here. In these two terms the common factor is 2x. Now x times something gives me minus 23x, well that's minus 23. And 2x times something gives me plus 4x, well that's plus 2. So our factorizing becomes x plus 2 times 2x minus 23 equals 0. So we have x equals minus 2 and we have x equals 23 divided by 2. But they're asking us to find the coordinates of the points of intersection. So let me just move this bit down for later on. Oh, what happened there? Okay, so I know that y is equal to, let's use a linear one, 3 minus a half x. It's easier for us to use this to find y. So when x is equal to minus 2, y is equal to 3 minus a half times minus 2, which is like 3 plus 1, which is 4. So one of the points is minus 2 and 4. And the other point, when x is equal to 23 over 2, y is equal to 3 minus a half times 23 over 2, which is 3 minus 23 over 4, which is like, alright, make that over 4. 4 3s are 12, so 12 over 4 minus 23 over 4, and that's going to give you negative 11 over 4. So the other point is when x is 23 over 2, y is negative 11 over 4. Alright, if I subtract, yeah, that's negative 11 over 4. So there are the 2 points where they intersect. Okay, 23 over 2, minus 11 over 4, and minus 2 and 4. And that kind of fits into what we saw here in terms of the values where they intersect. Okay, one is when y is positive, the other one when y is negative. Okay. Now, says write down using set notation the set of values of x for which p of x is less than q of x. So we need to look back at the graph. We had the points negative 2 and 23 over 2. 23 over 2 is like 11 and a half. Is that right? Yes, 11 and a half. So this is a point like 11.5, and this is the point negative 2. Okay, and we want to find, what does it say again? It says when p of x is less than q of x. When p of x is less than q of x. Okay, when p of x, I'll just use this earlier, p of x is less than q of x. Now, p of x is the line and q of x is the curve. Okay, they are equal to each other when x is minus 2 and when x is 11.5, 23 over 2. Okay, but p of x, which is the line, is less than q of x. Okay, you can see between here and here it's more than q of x, it's above q of x. We want to know when it's below it. So if you think about values in this region here, the line is below the curve. The curve is going to continue up this way, continue up that way. The line is going to continue like this. This curve is going to continue being steeper and steeper and steeper. This one will stay the same gradient. So from minus 2 and back, p of x will be below q of x. So when x is less than minus 2, not equals, because minus 2, they're equal to each other. And also when x is more than 11.5, more than 23 over 2, the same thing applies. When it's more than 23 over 2, this line is going to continue going down, this is going to continue going up. So p of x will always be below q of x when x is more than 11.5. At 11.5 itself, they will be equal. So that won't be the case. So when P of x is less than Q of x is between x is less than minus 2 and x is greater than 23 over 2. Now, what they want us to do is to write this in set notation. Okay, so it says write in set notation. So we got to write when x is less than minus 2 and when x is greater than 23 over 2 in set notation. Okay, so we can say x is such that, I'm going to put your brackets, okay, you're going to have x minus 2, x is less than minus 2, union with x is greater than 23 over 2. Okay, that's fine. X is less than minus 2, union with x is greater than 23 over 2. Because if you put intersection, that doesn't make sense because there's no common ground between them. So it has to be when x is less than minus 2 or when x is greater than greater than 23 over 2. And that's fine as our answer in set notation with our squiggly brackets. And here we have finished this question. Question number, I think it's 5. Yep.